Today in our lesson we will be talking about parallel lines and the triangle angle sum theorem. The triangle angle sum theorem tells us that the sum of the measures of the angles of a triangle is 180 degrees. And when we're referring to the sum of the measures, or the angles in this case, we will be talking about what we consider to be interior angles. If we are looking at angle X, angle Y, and angle Z. Based upon our theorem here, we are told that the sum of those three angles will always equal 180 degrees. For time's sake, we will wait until class time to actually show or prove this. For this purpose, or for this video, we will actually use that statement and apply it. Let's take the following triangle. We have triangle ABC. And we are told that angle A is 35 degrees and angle C is 65 degrees. We want to know or to find the measure of the missing angle measure. In this case, it is angle B. Based upon our triangle angle sum theorem, the sum of our three angles equals 180 degrees. Now, we can either use this to represent it as X, or if we wanted to call it angle B. It's up to you. X plus 35 plus 65 will equal 180 degrees. Every triangle is this way. If we combine like terms, X plus 100 equals 180. Therefore, X equals 80 degrees. So the measure of angle B equals 80 degrees. Now let's take it a step further. We have the following triangle with an additional line inside. So technically we have three triangles here. We have the first triangle, the second one, and the whole triangle itself. We have a 65 degree angle, 39 degree, this angle here is 21 degrees, and we are wanting to solve for X, Y, and Z. Now, first thing we can do is we can look to the smaller left-hand triangle and know that we can solve for X. X plus 65 and 39 will equal 180 degrees. They form a triangle, so their sum will always equal 180. So X plus 104 equals 180. X equals 76. So if we want to, let's plug that in so we can see that in our drawing as we go. Now, we're also looking for the measures of angle Y and the measures of angle Z. If we look closely and carefully, we see that both X and Y form a line. And we know that those two angles are supplementary as well. So X plus Y equals 180. But we know X to be 76. 76 plus Y equals 180. Therefore, Y is equal to 104. And lastly, angle Z. Angle Z is in this smaller triangle here. And if we notice, we have a 21 degree angle, angle Z, and angle Y, which is now 104. We can use these two angles in Z to solve for Z. The three angles added together will equal 180 degrees. 104 plus 21 plus Z equals 180 degrees. Combining like terms, we have 125 plus Z equals 180. Z now equals 55. Let's now dig a little deeper. What if, in this particular example, we had no clue what X or Y were, and we were asked to solve for Z? Well, the way that we can look at it is we still have this angle, this whole angle, and angle Z as well. So we could use the whole big angle if need be, or a whole big triangle if need be, to solve for the value of angle Z. Now, this angle is not 39 or 21, but it is the sum of both of those. So 65 plus Z plus these two angles, I'm going to represent it in parentheses to show that it is one angle, equals 180. Now, if we were combining like terms or solving, 39 plus 21 plus 65, we would have Z plus 125 equals 180, and Z still equals 55. So there always are possibilities to find answers or solutions in different ways. Let's go and talk about our exterior angles for a triangle. Now, an exterior angle of a polygon, we'll talk about polygons a little bit more, but we can actually look at it and just think of it in our terms right now as a triangle if we want. So an exterior angle of a triangle is an angle formed by a side and an extension of an adjacent side. Well, here is my side, and I have taken the adjacent side and I have extended it out. Therefore, this is the exterior angle of the triangle. We know that all the other angles are inside, but we have this being our exterior angle. Now, exterior angles, we also have what are called remote interior angles. For every exterior angle, there are two remote interior angles. And these two remote interior angles are the two non-adjacent angles from the exterior angle. Why is that so important? Well, you guessed it. There's a theorem that goes along with it. And it is called the triangle exterior angle theorem. Let's move that over so we can see it better. What does it say? The measure of each exterior angle, so we're looking at this angle here, exterior angle of a triangle, equals the sum of the measures of the two remote interior angles. The sum of the measures of the two remote interior angles. So what this tells us is if I have angle X, angle Y, and angle Z, since angle X is an exterior angle, and angle Y and Z are its two remote interior angles, the measure of X equals the sum of the measures of angles Y and Z. Now, most of you probably just look at it and say, well, X equals Y plus Z. That is correct. So let's put this in an actual algebraic form. Say we're told the measures of two angles. What if we are given that angle Y is, let's say that it is 80 degrees. And we're told that angle Z is equal to 60 degrees. We want to find the value of X. Well, based upon our theorem, X equals 80 plus 60. Therefore, X equals 140 degrees. I hope everything has worked out for you. Please, if you have questions, either comment on the blog or write them down, and we'll look at them the next day we get to an opportunity in class.